Okay, so the next question that we have here is a question number 21, which is find the equation of the line which is equidistant from parallel lines, which is so the line is equidistant from parallel lines. So you have basically 9x plus 6y minus 7 is equal to 0, and 3x plus 2y plus 6 is equal to 0. So you have these two lines, and you have another third line which is basically equidistant from these lines. You want to find the equation of that line. I did try to solve this line in this problem in a different way, but it took me around an hour or so to figure out I needed to figure out a couple of things, but well, it didn't really work out. And there is a very simple solution here, meaning that suppose that, for example, there is a point. Suppose that there is a point, for example, h comma k. There is a point h comma k that is equidistant from these two lines. So of course, if you have, for example, if you have some point over here x1 comma y1, and if you have some line, for example, ax plus by plus c is equal to 0, that is the perpendicular distance of this point from this line is going to be equal to d is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. Square root of a squared plus b squared. Now if the line is 9x plus 6y minus 7 is equal to 0, and if the point is, for example, let's say h comma k, and if the point is basically h comma k, so then what we have is basically the distance of this point from this line is going to be equal to basically the absolute value of basically 9 times h plus 6 times b times y1, which is 6 times k minus 7 over the square root of 9 squared plus 6 squared, which is equal to 81 plus 36, which is equal to 711. So that is one thing, and I can call it, for example, d1, meaning that of course I can call this, I've called this line 1, so I call this d1. Now the second line that I have is 3x plus 2y plus 6 is equal to 0. This is number 2, and the point that I have is this, again the same, h comma k. Now d2 is going to be equal to the absolute value of ax1, so 3 times h plus 2 times k plus 6 over the square root of 9 plus 4 is equal to 13, the square root of 13. So now since this point, since the point h comma k is equidistant from the two lines, of course you can say that d1 is equal to d2. And if d1 is equal to d2, then you can say that basically 3h plus 2k plus 6, the absolute value of that over the square root of 13, is the same thing as the absolute value of 9h plus 6k minus 7 over the absolute square root of 117. And what that means is that I think 117 is divisible by 3 somehow, which is 39. So 117 divided by 3 is equal to 39 divided by 3 is equal to 13. So that's 3 square root of 13. So you can write this as 3 times square root of 13. So then square root of 13 and square root of 13 you can cancel out. And if I multiply this by if I multiply the numerator by a factor of 3, I will get 3 times the absolute value of 3h plus 2k plus 6 is equal to basically the absolute value of 9h plus 6k minus 7. And well, what that means is that then you can write basically 3 times 3h plus 2k plus 6 is equal to plus or minus 9h plus 6k minus 7. So now either basically 3 times 3h plus 2k plus 6 is equal to positive 9h plus 6k minus 7, which means that 9h plus 6k plus 6 is equal to 9h plus 6k minus 7. And then what that means is that 6 is equal to negative 7, which is not true. So this is impossible. This is not possible. Or you can say basically 3 times 3h plus 2k plus 6 is equal to negative 9h negative 6k plus 7. And that is 9h plus 6k plus 18. Oh no, I made a mistake here. I'm sorry. I did make a mistake here. So here you have 9h plus 6k plus 18. Well, of course that's not possible, but 9h plus 6k minus 7, and of course 9h you can cancel out with this, 6k you can cancel out with this, and there you have 18 minus is equal to negative 7, which is, well, not true. Not true, so basically this is not possible. Now 3 times 3 is equal to 9h plus 6k plus 18 is equal to negative 9h negative 6k plus 7. So if I take everything to one side of the equation, I will get basically 9h plus 9h plus 6k plus 6k plus 18 minus 7 is equal to 0. Okay, so that is 18h plus 12k plus 11 is equal to 0. That is some relationship between h and k. That is some relationship between h and k. And I know that the slope of this line is basically negative 3 to 2. Because the slope over here is basically negative a to b, so it's negative 3 to 2. So your m is equal to negative 3 to 2. So so that has to have the same slope as well, meaning that so now if the line that I want to have to find the equation of, if the slope is negative 3 to 2, that means that negative a to b is equal to negative 3 to 2. Okay, so now there is basically, if you paid attention to the process that we went through to get this relationship between h and k, so basically what we did was that we said that there is some point h over here. There is some point. We said that there was some point basically with the coordinates h comma k, and this point was basically equidistant from both of these lines, and then we found the distance of the point from the first line, we found the distance of the same point from the second line, and then we equated the two distances d1 and d2, and then we got this equation, this relationship, and there basically we got these two cases because we had the absolute value function, and one of these cases was not, of course, acceptable because it gave us some garbage answer. It was 18 was equal to negative 7, which is of course not even true, and so one answer that we got over here was basically 18h plus 12k plus 11 is equal to 0, meaning that there is this relationship between the x coordinate of that point and the y coordinate of that point. 18h plus 12k is equal to 11 plus 11 is equal to 0. Now since we are talking about a straight line, when you talk about a straight line, the characteristic of a straight line is that if you find, for example, let's say that we have this line over here, for example, y is equal to x. This is your x-axis and this is your y-axis. So what the characteristic of this line over here is that whatever point you pick on this line, this relationship does exist between each pair of those, basically each of those basically ordered pairs, meaning that, for example, let's suppose that you take over here x1 comma y1. Over here you can take x2 comma y2, over here you can take, for example, x3 comma y3, and so on and so forth. Whatever point you take over here, this relationship does exist between these ordered pairs, meaning that if the general rule of this line, which is the equation of the line, is y is equal to x, then at this point you can conclude that y2 is equal to x2. At this point you can conclude that y1 is equal to x1. At this point you can conclude that y3 is equal to x3, and so on and so forth, all the way to y of n is equal to x of n. So this happens in a straight line because based on how a straight line works, when you have a single relationship between these points, and this single relationship is kept basically constant all along that line, basically all throughout the points that lie on that line. But there are some cases meaning that, for example, in this case, x basically changes with y under this condition, that, for example, whatever the value of x is, that is the value of y. Now you can have, for example, a different situation, meaning that, for example, let's say that the slope of this line is 2, for example. Let's say that the slope of this line is 2, and so this becomes y is equal to 2x. So what this means is that now whatever point you pick on this line, for example x1, y1, based on this rule, your y1 over here is equal to 2 times x1. If you pick this point over here, x2, for example, y2, over here again you can conclude that y2 is equal to 2 times x2. And you can just keep going on, and you can conclude that y of n is equal to 2 times x of n. So this is what happens in a straight line. In a straight line, and of course it goes the other way around, meaning that the converse of that is also true, meaning that suppose that you find a straight line over here. Suppose that you find a straight line over here, and suppose that the straight line is just like this, and then you pick a point on this line, and then that is x1, for example, y1, and whatever sort of relationship you can find between x1 and y1 at this point, the same type of relationship is going to be valid at any other point that you pick on this line. And so, for example, if x1, if the relationship between x1 and y1, for example, at this point is, for example, y1 is equal to 2x1, for example, plus 3. If that relationship exists here, then you can say as a general rule that y1, not y1, but y is equal to 2x plus 3, meaning that this is a general relationship that applies to every point on this line. But well, this applies to all basically straight lines. But suppose that you have a function like this, for example, and the function is something like this. You have a function like this. So you can see that the function over here, this function over here is basically increasing, meaning that as you increase your x's, your y's are increasing. If you had some line like this function would be decreasing. As you increase your x's, your y's are decreasing. But you see that over here there is no rule like this that you could say that this function is either increasing or decreasing. Over here it is increasing. Over here it comes to a peak. Sorry, just got confused. Over here you come to a maximum, for example, then over here you are decreasing. Over here you come to a trough, and over here again you are increasing, and so on and so forth. And of course the rate at which the function is increasing and decreasing is different. For example, over here the function is decreasing much faster than basically compared to the rate of change at this point. At this point, the rate of change is much more slower than this part over here. So when you have a function like this, then you cannot, for example, you cannot say that, for example, you cannot just pick a point over here and find some relationship between x and y at that point, and then generalize it to all points on the graph of the function, because well, as you can see, the function is behaving differently from moment to moment, from point to point. So this kind of thing doesn't work here, but it does work in the case of linear functions. Now, I said all of this because I wanted to show you this, and based on that I wanted to conclude that basically, since now I got at some point h and k, I got this relationship between h and k, I can generalize it to every point on the graph of the function and say that instead of h I can write x, instead of k I can write y, and I can write 18x plus 12y plus 11 is equal to 0. And you can see from here immediately that basically we said that this line was supposed to be parallel to those two lines. This line was supposed to be parallel to those two lines, and you can see that over here the slope of this line is negative 18 to 12, which is basically divided by 6 you'll get 3, divided by 6 you'll get 2, which is equal to negative 3 halves. And the slope of this line over here, the slope of this line over here is negative 3 halves. The slope of this line over here is negative 9 by 6, which is equal to negative 3 halves. So you can see that this is exactly, this equation over here is exactly what we were looking for. And basically that is the equation of the line that we were looking for. So that is the solution of this problem. So that's basically that. Now the next thing that we have over here is question number 22. But of course, as you can see, these questions do take a long time. But of course, the concepts that you can understand through these questions, there is no other way to understand these concepts in any other way. You have to basically solve good questions and solve good exercises in order to understand these concepts in practice. Otherwise, you would never really understand them. So we have 3 questions left from this chapter. We will do these as well, and then we will hopefully sometime get into the next chapter, because this is taking way too long, really. Okay, so the next question that we have here is a ray of light passing through the point 1, 2 reflects on the x-axis at point A, and the reflected ray passes through the point 5, 3. Find the coordinates of A. So you have basically this. Okay, so now in order to solve this problem is not really very straightforward, but you can find it. I mean, you can solve the problem, and it's actually an interest, and not, well, it is interesting, of course. It's not uninteresting, but it's an important problem in physics, and I'll show you what I mean by that. So basically, there is a ray of light that comes in at this point 1, 2. So you have 1, 1, 2. So this point over here, and then that's the incident ray, and then there is a reflecting ray that goes out through the point 5, 3. So 2, 3, 4, 5, 3 is basically this point over here. So that means that the point that the ray comes in here and then goes out here. So somewhere over here, basically the ray hits the x-axis. Somewhere over here hits the x-axis and then goes out. And of course, you know that if I draw a perpendicular to the x-axis, this angle over here is called the angle of incidence, and this angle over here is called the angle of reflection. And of course, this is not I mean, the slopes that my lines have are not very indicative of that phenomenon, that these two angles are supposed to be the same or equal. but these two angles are supposed to be the same angles. For example, I can call this phi, and then this angle would also be phi. So if that is the case, then let's suppose that this is the x and y axis, and I call this is point 1 comma 2, this point is 5 comma 3. Call this point, for example, C, call this point, for example, B, and call this point, for example, A. And let's suppose that the coordinates of A are A comma 0. Okay. Now what you want to do, you want to find the coordinates of this point where the ray hits the x-axis and gets reflected back up. So what basically the way that you can solve this problem, of course there is a way to, well, of course that would be doing unnecessary things. The way that you can solve this problem is that you know that basically this, you can call this angle, for example, theta, and if this angle is theta, and if this is if this basically line over here is perpendicular to the x-axis, then this is going to be a 90-degree angle, and this is going to be a 90-degree angle. And since these two angles are equal, then this angle is also going to be equal to this angle, meaning that this angle is going to be also theta. Or in other words, you can say that if I call this point O, angle basically LAO is equal to angle LAX is equal to basically 90 degrees. So now if that is the case, then of course you know that angle LAO is equal to angle phi plus this angle over here. So this is phi plus this angle over here, which you can call BAO, angle BAO. And angle LAX is equal to phi plus theta. So now if these two angles are equal, that means that you can just simply simplify phi and phi, and so that means that basically angle BAO is equal to theta. So then this angle is equal to theta. So that is that. Now basically now if this angle over here, if this angle BAO is equal to theta, then angle BAX, which is the supplement of that angle, so that means that basically angle BAX is equal to 180 degrees minus theta, because the sum of these two angles is 180 degrees. Now you can calculate the tan of this angle theta. So the slope of this line AC, is equal to tan of theta, which is equal to, now tan of theta over here, you can imagine that you have this triangle over here, and theta is this angle over here. So if you have this triangle over here, and you have basically this triangle, and this is your theta, then tan of theta is going to be equal to, for example, if this is A and this is B, is going to be A divided by B, opposite by adjacent. So now this height over here is 5, as you can see over, is 3, as you can see over here is 3, and this height over here is 3, and this length over here is basically, you see this point, that the x coordinate of this point is 5. The x coordinate of this point over here, is A. So that means that basically the length of this this length from here all the way up to here, this is 5, and this length over here from here all the way up to here is A, right? So what that means is that then if you were looking for basically this, if you were looking for this length over here, say that if you were looking for this length over here, you could, so we said that basically this whole length is 5 and this length is A, so then this length is basically, this length would be 5 minus A. This length over here would be 5 minus A, because the whole length is 5 and this part is A, so this part over here is 5 minus A. So you can write this as 5 minus A. And then basically the next part is that, now imagine that you have basically this angle over here is also theta, and if you were to calculate tan of theta from this triangle, you would say you would write tan of theta is equal to basically this, the height. For example, if you imagine that you have this triangle over here, you would have this height over here and this length over here, and you would divide this length by this length. So then that would give you basically the height is 2. The height is 2, and this length over here, the length all the way up to here is A, and the length all the way up to here is 1. So this part over here becomes A minus 1. A minus 1. So then you can write tan of theta is equal to 2 over A minus 1. 2 over A minus 1. So now we have some relationship between tan of theta here and tan of theta here. So since tan of theta is equal to tan of theta, then you can write basically 3 over 5 minus A is equal to 2 over A minus 1. So if you cross multiply, you get 3A minus 3 is equal to 2 times 5 is equal to 10 minus 2A. 3A plus 2A is equal to 10 plus is equal to 13. 5A is equal to 13. And A is equal to 13 fifths. So that means that the coordinates of the point A are basically 13 fifths and 0. So 13 fifths comma 0. And that is basically how you can solve this problem. The solution that I can find over here is a little bit unnecessarily complicated, but then I tried in many different ways to solve this problem, and that seems to be the best way. Although, as I mentioned before, it's not a very straightforward problem, but very important in terms of physics and so on and so forth. So it's important that you understand it properly. So now the next question that we have is question number basically 23. Prove that the product of the lengths of the perpendiculars drawn from these 2 points to this line is b squared. Okay, so you want to prove that the product of the lengths of the perpendiculars, prove that the products that the product of the lengths of the perpendiculars drawn from the points drawn from the point the square root of a squared minus b squared, comma 0, and negative square root of a squared minus b squared, comma 0, from these 2 points to the line x over a times cos theta plus y over b times sine theta is equal to 1. The length is basically that that is equal to, let me write it this way, is equal to b squared. So now first we need to understand the problem. So now the problem is that the product of so this b squared is the product of the length of the perpendiculars drawn from these 2 points to this line. So suppose that you have a line, for example this line over here, and you have 2 points and you draw 2 perpendiculars. For example, the situation is like this. Suppose that you have a line over here and you have basically, for example, 2 points, for example, both on the x-axis. For example, this point over here and this point over here. And from this point I draw a perpendicular to this line. From this point I draw a perpendicular to this line. If I call this A and if I call this length B, then and these are basically the coordinates of these 2 points, and this is the equation of this line, that basically A times B in this particular case is equal to, for example, b squared. So b squared is basically this product over here. That's basically the problem that you want to solve. And so now let's see how we can solve this problem. Okay, so I did try to solve the problem, but I got to some problems over here, and now I will do this again. Actually, when you try to solve the problem, even if you cannot solve the problem on your own, but I mean, if you do try to solve the problem on your own, you will get to some points where you see what the problem. I mean, for example, you see a piece of knowledge somewhere over here, and you don't have that piece of knowledge, or for example, you need some sort of, for example, some sort of skill in algebra. For example, usually it comes down, it boils down to, for example, at least in my particular case, for example, it's usually, for example, the square root function, or usually the square root function is the square root function is the kind of thing that in different situations you have to deal with the square root function, for example, in different ways, meaning that you need to understand the situation. Otherwise, when you want to simplify this some square root function of some argument, having some argument, you will run into logical problems, and so when you try to solve a problem on your own, you will get to know about your own problems for example, in algebra or in any other area of mathematics, that wherever that might be. And that is basically a very, very valuable source of insight that you could have. And then if it's possible, and of course it's always possible, it's always possible to go back to wherever the problem is. You can go back and read the basics and then come back to and solve the problem. So for example, right now I was kind of stuck in the algebra because I got into some square root function. I couldn't decide what to do with that square root function, and so then I basically erased the whole recording, and then I'm recording again. So it's always basically meaning that what I probably want to say is that it's always a good idea to, whatever sort of problem that you have, that you give it a go on your own before you try the solution. And then of course, if you can't do it on your own, at least you know what you don't know, and then you can use the solution, and of course whenever you use the solution you will learn a lot from the solution as well. So okay, so now basically we want to prove that the product of the lengths of the perpendiculars drawn from these 2 points to this line over here is b squared. Now the equation of the line is x divided by a cos theta plus y divided by b sin theta is equal to 1. This is the equation of the line, and or you can write this equation as I can multiply this equation by a times b, meaning that I can write a times b times x times cos theta over a plus a times b times y times sin theta over b is equal to a times b. And then I can simplify these, and then you will be left with basically b times, or basically bx cos theta plus ay sin theta is equal to ab. So I can call this, and of course I can write this as bx cos theta plus ay sin theta minus ab is equal to 0. That I can write equation that I can call equation number 1. Now the length of the perpendicular from this point, now the length of the perpendicular from the point the square root of a squared minus b squared comma 0 to this line, to basically to the line 1 is basically they have called it P1, I would call it the same thing. So the formula is, as you know, is basically d is equal to the square root of, the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So, and here basically we are assuming that the line is ax plus by plus c is equal to 0, and the point is x1 comma y1. So that is basically the formula that we use over here. And so now, since if that is the case, then I can write, for example, P1 is equal to the absolute value of ax1. So a over here is basically b cos theta times b cos theta times this. So it's b times cos theta times x1, which is the square root of a squared plus b squared. A squared plus b squared. And ay sin theta, so basically b times b times y1, so b is a b is basically a sine theta times y1, which is equal to 0, plus c1 plus c, which is equal to negative ab. So you have the absolute value of that over the square root of b squared cos squared theta, which is basically a squared, b squared cos squared theta, plus a squared sine squared theta. That is the length of perpendicular, and so that is equal to basically the absolute value of b times cos theta times the square root of a squared plus b squared minus ab over the square root of b squared cos squared theta plus a squared sine squared theta and the length of the, and so now the length of the perpendicular from basically the other point, which is negative square root of a squared minus b squared, comma 0 to the line 1 is, call it for example P2, so that is equal to so the only thing that changes here is basically the point over here, meaning that you get the negative sign over here. So you can write this as b the absolute value of b cos theta times negative of the square root of a squared minus b squared plus ab, or it has to be negative ab, okay, so you can write it as negative ab over the square root of b squared cos squared theta plus a squared sine squared theta, and then you can write this as basically, and this is an absolute value function, so I can so from these two terms I can take a negative one out, and if you take the negative one out, for example, let's say that you have for example negative a minus b, the absolute value of that, you can write it as the absolute value of negative 1 times, for example, a plus b, which is of course equal to the absolute value of a plus b, because the absolute value of a plus b when a plus b is positive is going to be a plus b, so you can take the negative one out and just simply not write it if you want to or if you need to. So then you can write this as b times cos theta is equal to b times cos theta times the square root of a squared minus b squared plus ab over the square root of b squared cos squared theta plus a squared sine squared theta, and so that is P2, b cos theta square root of a squared minus b squared plus ab over b squared cos squared theta plus a squared sine squared theta. Now if I can call this equation, for example, number 2, and I can call this equation number 3. Now if on multiplying equation 2 and 3 we obtain, basically we wanted to find the product of the lengths of the perpendiculars drawn from these 2 points. So now that we have found the two basically perpendiculars, which is basically P1 and P2, I can write P1 times P2 is equal to basically these two multiplied together, which is basically the absolute value of b times cos theta times the square root of a squared plus b squared minus ab over the square root of b squared cos squared theta, b squared cos squared theta plus a squared sine squared theta. And you want to multiply this by this thing over here, which is the absolute value of b times cos theta times the square root of a squared minus b squared plus ab over the square root of b squared cos squared theta plus a squared sine squared theta. Okay, so that's P1 times P2. And that is so now you can write this as, now this is, I mean, the interesting part is here where you want to basically simplify this thing, because while you're simplifying this thing there are some steps necessary which are valuable steps to learn, and then when you learn those steps, then you can apply it to anywhere, wherever you happen to end up in algebra. Whatever you learn here, you can apply it over there as well. Okay, so now the rest of this, let's basically get this done. So the rest of this would be where was I? Now, one important thing that we have over here is basically when you have basically some expression in let's suppose that, for example, you have some expression over here in an absolute value function and some other expression in an absolute value function. The product of the two absolute value functions along with the expressions, the arguments of the absolute value function, you can write them as basically, you can write it like this, meaning that you can write it as, for example, the absolute value of for example, suppose that you have, for example, the absolute value of -4 times the absolute value of 3, right? So this is going to be equal to 4 times 3 is equal to 12. Now I can write this as the absolute value of -4 times 3, which is equal to the absolute value of -12, which is equal to 12. So that means that the absolute value of A times the absolute value of B is equal to the absolute value of A times B, irrespective of the fact that whether A or B are 0, a negative value, a positive value. So you can always do that without having to make any sort of assumption. So then based on that you can write basically b cos theta times the square root of a squared plus b squared minus ab times b times cos theta times the square root of a squared minus b squared plus ab, and then you have the absolute value of the whole expression. And over here you have b squared cos squared theta plus a squared sine squared theta, which if you basically write this as, you can write this as the absolute, the square root of b squared cos squared theta plus a squared sine squared theta, and when basically these multiplied together, you can write it as this whole squared, and of course you can write this as, and this is basically one of those spots where you have to basically pay attention to what you do, meaning that, for example, when you raise the square root of some expression to the second power, what that means is that, for example, let's say that you have for example, I don't know, you have the square root of 9 whole squared. The square root of 9 whole squared. So the square root of 9 whole squared can be plus or minus 3, because I'm sorry, it can be basically only 9, because but the other way around, if you have for example, so what that means is that it can be only 9. So what that means is that when you have this expression, you can simply write it as b squared cos squared theta plus a squared sine squared theta. Okay, there is no problem with this. But now suppose that you have, for example, a squared. You have some number a, and you have some number a. For example, suppose that you have negative 3 over here. Negative 3, if you raise it to the second power, you will get a 9. If you have a positive 3, if you raise it to the second power, you will still get a 9. That means that the square root of 9, is actually equal to plus or minus 3, because positive 3 whole squared is equal to 9, and negative 3 whole squared is also equal to 9. So what that means is that if I have the square root of some expression is equal to some other expression, if I raise this to basically well, let's not confuse ourselves here, because this is like a vicious circle, and I don't want to confuse myself here. But basically, whenever you have basically the square root of basically, for example, let's say you have the square root of 9. If you have the square root of 9, it's simply equal to 3. Or of course you can say that the square root of 9 can also be equal to negative 3. It can also be equal to negative 3 if you're not dealing with the principal square root function. If you're dealing with the ordinary square root function, then the square root of 9 can be plus or minus 3. Plus or minus 3. Okay. Now there is some other case. Now I will basically find a good example in order to basically to explain this, but for now I don't want to explain. I don't want to confuse myself, nor do I want to confuse you. So for now we are just simply assuming that whenever you have the square root of some expression, some expression, and this expression is always going to be positive, of course. This is always going to be positive because this is b squared cos squared theta plus a squared sine squared theta. This is always going to be positive. But I will find a good example to show you the different ways that the square root function can be troublesome in different situations, and then we will talk about that, because that was mainly one of the reasons I could not basically get to the end of this exercise on my own. So, and this is basically important when it comes to applications of mathematics. For example, in physics, if you don't understand the square root function properly, then you can get into trouble, for example, in physics. But for now, just to get to the end of this exercise, what basically we are going to assume that when you have the square root of, for example, this expression, if you raise it to the second power, then you can simply write down the argument of the square root function as it is: b squared cos squared theta plus a squared sine squared theta. And that's basically the whole story for now. We will basically I will basically find some good example, and I'll demonstrate this to you in using some very good example. Okay. So now what this is that this is basically b cos theta, the square root of a squared plus b squared minus ab. B cos theta is square root of a squared plus minus b squared. This is, why is it plus b squared? Why is it plus b squared? P1 is negative. This is supposed to be minus b squared, of course. My mistake, I apologize. So negative. So you see that over here you have b cos theta square root of a squared minus b squared minus ab. B cos theta square root of a squared minus b squared plus ab. So you can take this whole thing as a and this whole thing as b. So this is a minus b times a plus b, which is the same thing as a minus b times a plus b is equal to a squared minus b squared. So I can write this as basically the absolute value of a squared, which is b squared cos squared theta, and then times a squared minus b squared, a squared minus b squared, raising this to the second power, a squared minus b squared. So a squared minus b squared minus a squared b squared minus a squared b squared, and you want to divide that by b squared cos squared theta, b squared cos squared theta plus a squared sine squared theta. And what that is, so you have b squared cos squared theta times a squared minus b squared minus a squared b squared. So you can take this out. No, you cannot take that out, but you can take b squared out from here. You can take b squared out from here. So you have a squared b squared cos squared theta, a squared b squared cos squared theta, b squared cos squared theta. Okay, so you can write this whole thing. So I can write this thing as basically I can multiply this a squared times, so I have a squared b squared cos squared theta minus b raised to the power 4, b raised to the power 4 cos squared theta minus a squared b squared over b squared cos squared theta plus a squared sine squared theta. So over here I have a squared b squared cos squared theta minus b raised to the power 4 cos squared theta minus a squared b squared over this whole expression. And now you can take the b squared out, and this is all in an absolute value function. So now if I take the b squared out, I can write this as basically the absolute value of basically b squared times a squared cos squared theta minus b squared cos squared theta minus a squared This is a squared cos squared theta minus b squared cos squared theta minus a squared over b squared cos squared theta plus a squared sine squared theta. And so I can take this whole thing out, meaning that I can take this out because it's a positive value. So b squared, the absolute value of a squared cos squared theta minus b squared cos squared theta minus a squared over b squared cos squared theta plus a squared sine squared theta. And so over here, let me check. I have b squared times a squared cos squared theta minus b squared cos squared minus a squared. And of course, these are not necessary anymore. Time over b squared cos squared theta plus a squared sine squared theta. And so here I have a squared cos squared theta minus b squared cos squared theta minus a squared sine squared theta minus a squared cos squared theta. Okay, so over here you need to rewrite this in such a way that 1 is equal to sine squared theta plus cos squared theta, right? So over here you have this a over here, a squared over here. So if you write this a squared cos squared theta minus b squared cos squared theta minus a squared sine squared theta minus a squared cos squared theta. Okay, so what you can do here is that basically you can write this as b squared, the absolute value of a squared cos squared theta minus b squared cos squared theta minus a squared, and there is a 1 multiplied by this a squared, of course, and you know that basically sine squared theta plus cos squared theta is equal to 1. So instead of 1 over here I can write sine squared theta plus cos squared theta. Okay, and then this is my absolute value function, and here is my denominator. So b squared cos squared theta plus a squared sine squared theta. Of course, these are the kind of things that you would never expect to do, or you would actually, I would never be able to figure out, for example, what to do in this step or something like that. But these are the little things that you get to learn along the way, and then of course you're looking over the solution, meaning that not every problem, it's not possible to solve each and every one of these problems on your own, because sometimes they have twisted things in different ways, But again, when you look over the solution, you will get to learn many useful things along the way, and they will help you in many different ways in many different places. That's the point. Otherwise, if you try to do this whole thing on your own, you could actually drive yourself crazy, and you might actually never be able to do it. So you need to be careful about that. So I can write this as basically, I can write this as b squared, the absolute value of a squared cos squared theta, minus b squared cos squared theta, minus a squared, multiply this a squared sine squared theta, plus minus a squared cos squared theta, and then you have b squared cos squared theta plus a squared sine squared theta. So over here I have a squared, basically a squared. So you have here basically all of these are negative except for this one. So negative b squared cos squared theta, and here I have a squared. So if I have somehow you can get a 1 out of one of these. Meaning that cos squared theta, cos squared theta, cos squared theta plus sine squared theta, b squared cos squared theta plus a squared sine squared theta, and then that would be okay. So now, as it turns out, you can make some changes to this, and it becomes exactly this expression, and then you can simplify them, and you'll be left with b squared. But to get this denominator out from this part of the expression over here, what you need to do is that basically you get a negative out of probably all of these. Let's see what happens. So if you get negative of a squared cos squared theta plus b squared cos squared theta plus a squared sine squared theta plus a squared cos squared theta, and then so over here, for example, you have b squared cos squared theta so over here I have so this is a negative, of course. There I need a negative because this becomes positive. So a squared cos squared theta, a squared, negative a squared cos squared theta, a squared cos squared, these two would cancel out, and then you have, well, the same thing, b squared cos squared theta plus a squared sine squared theta. That's how you do it. So if you take a negative out, these two will cancel out, and then you will be left with this exact thing. So I'm going to rewrite this as basically b squared, this the absolute value of negative of b squared cos squared theta plus a squared sine squared theta, and then divide that by the same thing, b squared cos squared theta plus a squared sine squared theta, and then you can basically, if you take this out, you can forget about the negative sign, assuming that this is a positive expression. which is always a positive expression, of course. So you can write this as b squared times b squared cos squared theta plus a squared sine squared theta over b squared cos squared theta plus a squared sine squared theta. And you can cancel these two out and you'll be left with b squared, which is what we wanted to show. So that's basically that.